Hello guys, today we are going to talk about how to implement quicksort in Java. Quicksort is one of the fastest sorting algorithm. It is based on divide and conquer mechanism. Quicksort first select a pivot and partition the array around the pivot. On one partition it will contain all the elements which is lower than the pivot, and on the other partition it will contain all the elements which is higher than the pivot. There are multiple mechanisms to pick a pivot. It can be the rightmost element or leftmost element or median element, or it can be any random number in the array. Selection of the pivot doesn't affect the complexity of the time complexity of the algorithm. Now let's talk about how this algorithm is implemented. Let's take an example of a integer array. So let's take the example of an array of 1, 10, 8, 3, 5, 2, 7. So this is a 0, 1, 2, 3, 4, 5, 6, 7. 7 the array contains 7 elements. Now let's start with the partitioning process. So in the initial status, the whole array is the partition. Let's call the partition 0. Partition 0. In this case, we need multiple variables. One is the pivot index. As I mentioned, we are going to there are multiple ways to select the pivot, but we are going to use the rightmost element as the pivot. So let's select the pivot index as 0, 1, 2, 3, 4, 5, 6, 6, and the value is 7. We need one more variable which holds the starting index of the partition. Since it's a whole array, the starting index is 0. Now we are going to start the iteration. During the iteration, we need two variables. One variable will hold the index from where all the elements on the right hand side, on the left hand side will be lower than the pivot. So let's call smaller than pivot, and the first value of this index will be start minus 1. Why is it start minus 1 is that we didn't process this partition until now, so we don't know any of the values are below the pivot. So in order to so that's why we selected a value which is lower than the start value, that is 0. And since this partition is the whole array and the start value is 0, the smaller than pivot for the first partition will be minus 1. And we need one more counter for the iteration, which will increase on every iteration will be, and we can start with the 0, and the value will be 0. Now we got all the variables. Now let's talk about how an iteration will go through. So let's go through the first iteration. Iteration 1. So as I mentioned, the initial value of the we have two variables for the iteration, smaller than pivot and counter. The first step is whether the value of the counter index and the pivot is same or different, or whether it's greater or less than the pivot. Now let's compare. The first counter at the value 0 is 1 and the pivot is 7. Now in this case, 1 is less than 7. That means 1 has to be in the left hand partition of the pivot. So what that means is we want to increase the pivot to smaller than pivot to is equal to smaller than index plus 1, and the value will be 0. And what we need to do is we need to do a swap between array smaller than pivot and counter. So in the first iteration, both the value of smaller than pivot and counter are both 0. So since we already increased both 0, there is no need of swap. So at the end of the iteration, we increase the counter to counter plus 1, and the value will be 1. Now let's go through the next iteration. Iteration 2. In this case, we again going to compare the value at the index 2 index 1, which is value 10, and the value at the index of the value of the pivot, which is 7. And in this case 10 is higher. That means 10 has to be in the right partition. So what that means is that we don't want to increase the smaller than pivot, because smaller than pivot, the only thing we are going to increase here is the counter. It's equal to counter plus 1 and will become 2. Now we will again go to the next iteration 3. The same scenario. That means we are not in the iteration 3, the counter value is 2 and the value at the index 2 is 8, and when we compare with the pivot, the value at the counter 2 is higher, so we don't want to do any swapping. So we just going to increase the counter value to the next one, that is 3. Now let's go to the iteration 4. So in this case, in iteration 4, the counter value is 3 and the value at the index 3 is 3, and when we compare with the pivot, this is lower. That means this value 3 has to be in the left hand side of the partition. So what you need to do is we have to increase the smaller than pivot to the next number. So it will become 1, and we are going to do a swap between the element at the smaller than pivot and the counter. So the output of this one, let me copy paste the array first. The output of the array will be 3 and 8. 10 will be swapped, so it will become 3, 10, and it will become 3. And we again increase the counter, become 4, and I'll just copy paste the iteration number 5. So in this case also, the value at the counter 4 is lower than the pivot, so we are going to do a swap. So before swapping, we again need to increase the counter smaller than pivot counter to 2, and we again do a swap. So let me copy paste this whole thing. We again do a swap, and in this case 5 and 8 will be swapped. 5 will become 8 and it will become 5. Now we'll go to the next iteration. Let me copy paste the whole iteration one more time. Okay, so in the iteration 6, the same thing. Iteration 6, we forgot to copy the counter. For the iteration 5, we'll increase the counter to 5. In the iteration 5, the element at the index 5 is 2. Again, we comparing with 7, which is the pivot. The 2 is lower, so 2 has to be in the left hand side of the partition. So we are going to again do a swap between 10 and 2. That is, it will become 2 and it will become 10. So at this point, the counter, and at the end of this iteration 6, the counter will be 6. And if you look at the initial values, the pivot index is 6. So now the counter and counter value and the pivot index are both same. So that will be end of this partition scheme. But at the end of the partition, we also need to do one more step. That is, we need to swap the smaller than pivot with the actual pivot. So we will do one more swap. Before doing the swap, we have to increase the counter of the smaller than pivot, because right now smaller than pivot is pointing to the value index value of 2. We have to move to 8. So we will do a +1, and that will replace 7 and 8. So what you see is that all the elements which is lower than 7 is in the left hand partition, and all the elements which is higher than 7 is in the right hand partition. So at the end of this partition, all this step, we have to return back the index of the pivot. So it will be return smaller than pivot. Okay, so that will return back or finish all the partitioning mechanism. So of the first partition 0. Now next step is we have again do the same step of partitioning or the left hand partition, and that will create again two more partitions, partition 3 and partition 4. So in this partition 4, and again we will continue the step until number of elements in a partition is either 1 or 0. So if any of this if that condition matches, we end that partitioning of that partitioning, and we return back. So at the end of this whole quicksort, this array will be in a sorted order. Now let's talk about how to implement this quicksort in Java. So first step is we will write a main class public static void main string. Now let's write it down. Write it down the method for quicksort. So public. Let's write it down as static method, static void quicksort. So we have three parameters. In first is an array, and start and end of this array. So why we need to pass the start and end? Because we are going to do this recursive call on the quicksort for every partition. Okay. Now we are going to do, now in this quicksort, first we are going to do this partitioning of this array, and then do a recursive call on the both the partitions again on again. So let's do a partition. We'll implement this method partition array. We'll pass to both the all the three parameters, and the output of this partition array will be the pivot index. So int pivot index, and we, as I mentioned, we are going to do a recursive call on both the partitions. So quicksort array, the first partition will be start to pivot index -1, and second one and is from pivot index +1 to end. Okay, quicksort. Now now let's see how we can implement the partition array. So partition array, let's implement one more static method, and as the return value will be an int, which is the pivot index, and copy paste it. And there are three parameters, int start, int end. Okay, so let's see how we can implement partition array. As I mentioned, the first step is define all the variables. We need pivot index as the pivot index. It is int pivot index is equal to end, because we are using the last element as the pivot. And then we need a one more variable for keeping the smaller than pivot value, that is int smaller than pivot, and which is one number lower than the start. Okay, and that will be end of all the and the counter variable we will define as a part of the for loop. So now just define the for loop. For in counter is equal to start and counter less than pivot index counter plus plus. Now with this, we are going to implement the for loop. First step is checking. So if you look at this implementation, the first step is checking whether the value at the counter is less than pivot. So if the value of the counter is less than array pivot index, if it's less than that, that means it has to be in the left partition. So we have to do a swap. First, before doing the swap, we have to increase the smaller than pivot. So smaller than pivot is equal plus plus, okay, and then do a swap. Array smaller than pivot and counter. Okay, that will so that will finish all the for loop. And once the for loop is done, we have to, if you remember, these step has to, we have to do a we have to do a swapping between the smaller than next smaller than pivot with the actual actual pivot. So what we do is going to do is that swap array smaller than pivot plus 1, and we're going to replace with the pivot index, okay, and return, sorry, not pivot index, smaller than pivot plus 1. Okay, now let's implement the swap. Public static int swap array int array int I int j. For the fastness, I'm going to copy paste a simple swap method. Okay, sorry, there's no need of int, but it's a void. So that will finish the whole program for Quicksort. Let's test it out. So let's test it out. Let's create an integer array. Let's copy paste the integer array which we are testing. Okay, then we'll make a call, Quicksort call array 0, which is starting index, and ending is array dot length minus 1 plus, and fix all the syntax issues. Okay, so that's it. Let's run it. Okay, there is some issue. 1 second. So I think there is some. Let's see what's wrong with this. So okay, counter has to be pivot index, counter plus plus. Oh, you know what? There is one mistake. One step which is missed. That is, we didn't added the logic of when to end. So, as I mentioned, we have to stop this all this process the moment the number of moment the number of elements in the partition is one or less than 1. So what that means is that how we can test it out is whether the start and end start is we only need to process only if the start is less than end. That is, if start is less than end, then only we need to process, we need to do this. Otherwise, we know that we have we have either one element or zero elements in the partition. So we also do a print. We'll try to print it out. System dot println arrays to string array. Okay, so that concludes the implementation of Quicksort in Java. Thank you guys.